welcome you to the presentation.
Okay, thank you everyone. Thank you for your time and for being here. Again, we're doing diversity and inclusion, incorporating history into the mathematics classroom. We are at Arizona State University in the Phoenix, Arizona area. And let's look at the background. I'd like you to think about this statement from the Journal of Personality and Sociology, a study. The measure of the sense of belonging in a mathematics community is a predictor of achievement and desire to pursue future studies across the sciences. And I think we all can appreciate our interest in predicting achievement. But I want to take this statement and just sort of overwrite that with a sense of inclusion, because it override belonging with the sense of inclusion, especially in the sort of diversity and inclusion climate that we experienced here in the past couple of years here in the United States. And so one of the things I'd like you to think about as we move forward here, what if educators and students enter the classroom, and truth be told, we believe this as we pursue this research study, that they enter this classroom with misguided biases about how to learn mathematics, and misguided biases about the historical lineup of mathematicians, misguided biases about the general history of mathematics, and misguided biases about interconnectivity between history and math. And so as we stand on those assumptions, then I like to, first of all, call your attention to this image here that sort of sums up how we pursue the study of mathematics in terms of the fields of mathematics, and how as we pursue mathematics, the things that we're talking about here sort of influence and affect students' ability to navigate and to matriculate through these fields. And so regarding math education, I think this has a huge impact on how students pursue mathematics, the techniques that we use to teach them mathematics. Also, the history. This is one of my favorite images here. It's the notes, or presumed to be the notes from historical mathematician Ramanujan, and the tools that we use to teach mathematics, and also the diversity, the people whom we reference as we are teaching mathematics. And so we're thinking about inclusion, and you can sort of glimpse across this lineup of mathematics and consider measures of, or areas of, inclusion. And so we believe that the history of mathematics is a very important pursuit as we move through the study of mathematics. And so I just want to also call your attention to a snippet from the textbook that we're using in this class. This is actually a pre-calculus classroom at a course at a university, and that was involved in this study. And so notice here, just a snippet. One of the major influencers of the content of Precalculus would be Galois, and this is all the textbook references regarding that mathematician. So we can sort of see that many even authors of textbooks don't have a firm understanding of the importance of the history of mathematics. And even students might say, can we focus on math? This actually happened as I introduced the project that I'm going to introduce to you all here today. Why are we studying mathematics, or why are we studying history? The students want to know in a math classroom. Someone, and I quote, "I thought we were here to learn about math." And so some of the measures of diversity that we are trying to introduce to the students to help them really see themselves in a mathematics classroom, we start with Ramanujan, and with respect to the content we're studying in the pre-calculus classroom, prime numbers would be his area of interest, and he was poor. He was East Indian. We consider that a measure of diversity, his ethnicity and his socioeconomic class. Hang, he redefined the approximation of pi. We consider him, in terms of his diversity, ethnically diverse. Sophie Germain, she had the idea for proving Fermat's last theorem for all primes. She's her gender, regarding her gender, we consider her diverse. Galois, he was a very young person. We consider him his measure of diversity. And also Euler, who was vision impaired. So these are some of the measures of diversity. We hope that students, as we pursue and seek the effects of exposing students to a diverse group of mathematicians, supporting diversity and inclusion in the classroom. So this is what we're going to do in our research procedures. We have 36 undergraduate students in a pre-calculus classroom, and we assigned a project in and out of classroom work, and we gave a pre-test and a post-test to sort of understand what are the effects of exposing students to a diverse group of mathematicians to support diversity and inclusion in the mathematics classroom. Can I get an update on my time, please? And so we addressed—
You have 4 minutes more.
Thank you. 6 multiple choice questions were given. You can see those questions here. We gave a pre-test in week 2 of the semester-long course and a post-test in week 10. Improvements were demonstrated for all responses, and significant improvement was demonstrated for some responses. And that's outlined sort of here. I'm going to breeze past that, of course. But we also analyzed the responses in the pre-test and post-test by and identified that 29.6% of students with at least 5 correct responses after treatment, which was an increase of 0% from the pre-test. A percentage of participants not able to provide any correct responses decreased from 13.9% to 3.7%. So we saw increases across the board. And the percentage of participants unable to respond on pre-tests decreased across the board because there were open-ended questions. Nearly half the class gained knowledge. And that's our point of emphasis here, gaining knowledge about one particular mathematician, Galois. Galois was the young person. His measure of diversity regarded his youth. Participants were able to list 3 elements of information about Galois, and their responses increased about alchemardisme from 2 to 5 pieces on average. Again, Galois was our measure of diversity, his youth, and alchemardisme, Middle Eastern. So his measure of diversity regarded his ethnicity and nationality. And there were open-ended questions. Which populations came to mind when we think of people who are best in math, and which populations come to mind when we think of people who are not good in math? Asians are good, Americans are not good. Again, this is a school in the United States. Our results, again, the question, what are the effects of exposing students to a diverse group of mathematicians? And we found that students gain new knowledge about historical mathematicians that expands their horizons about diversity. And very quickly, these are the measures of diversity, again, that we considered. Students of mathematics are mathematicians. We want them to believe this. And an increase of knowledge was demonstrated, and students continue to maintain bias toward Asians. And that's all. We, of course, have ideas for further research. And thank you very much for your time.
Thank you very much.